Well,
Do whatever.
and it seems a lot of students didn't really like my substitution method, so what I'll do is I'll just...
I enjoyed it.
You want
I
the
don't even
substitution?
know which one it is.
Okay, well, I'll just go and do this then. I'll just look at this and I'll say, you know what, guys? I really don't like dealing with cosines to the fourth and negative cosines to the fourth, right? And even with cosines to the fourth, I don't even really like dealing with numbers that are into the fourth power. So what I'm going to do is I'm going to see if how would I factor this if I was dealing with numbers that I like better. So rather than doing sine to the fourth, let's just say sine to the fourth of x equals x squared. Okay? And let's make cosine to the fourth of x equals y squared. Is that okay? Will that work?
Sure.
So now I have x squared minus y squared. Right? If I was going to substitute those in,
Yes.
right?
Yes.
Now, the same thing, if you're going to look at like your sine, I'll wait till that. So therefore now, how would I factor this? Well, this is a square number minus another square number, which we call the difference of two squares, right? So
Two squares.
x plus y times x minus y.
Yeah.
Done, factor, right? You guys should be able to do that real quick. Factor, done, got it. Well, if x squared is equal to sine to the fourth, x should equal just not sine to the fourth, but it's going to equal sine squared. Sine squared plus cosine squared of x, right? Times sine squared of x minus cosine squared of x. Does that kind of make sense?
Yes,
What I did?
Of course. Never made any more sense.
Well, let's think about it. If I look at my trig identities, sine squared plus cosine squared equals, you know, in some languages, that's how they were.
I don't think so.
Now we know that sine squared of x plus cosine squared of x
Equals 1.
equals 1. So how could I maybe, let's rewrite, how could I rewrite sine squared? If I rewrote sine squared, I could say sine squared is the same thing as 1 minus cosine squared, right? If I solve for sine,
Why would it be 1 minus cosine squared?
because I'm solving for sine right now, and when I solve for sine, I get 1 minus cosine squared of x, right?
Yes.
And what's so important about that is I know this goes to 1, but if I can rewrite sine as 1 minus, hold on a second, cosine squared of x minus cosine squared of x, yes.
So sine squared plus cosine squared equals 1. So wouldn't it be sine squared x minus cosine squared x equals 1 plus
Say that
cosine?
again?
Okay. So you're substituting 1 in for, go up a little bit. You're substituting 1 in for the sine plus, okay, then go down. Shouldn't that be sine minus cosine then equals 1?
So it's like 1.
No, sine plus cosine equals 1. That's what I'm saying. Sine plus cosine, that's equal to 1. That's the same thing. That's what I was saying. What I'm saying, sine squared plus cosine squared equals 1. So rather than writing that, I can just write 1.
Oh my god.
See what I got? Does that make sense though? Okay. So now I have 1 minus cosine squared of x plus minus cosine squared of x, which is going to, geez, I'm getting a lot of work.
I know.
1 minus 2 cosine squared of x.
Why? Just, can you like go?
Wait, why are we trying to find out the?
All I did was I just substituted in. Instead of writing sine, I wrote it in terms of cosine. So I got 1 minus 2 cosine squared of x. Because there's sine squared and cosine squareds, I can rewrite them, see if I can simplify it a little bit further.
Why is it 2 cosine?
Because a negative number minus another number is going to be negative 2 sine, or negative 2 cosine squared of x.